Afternoon, folks. This is Williams. Today's topic is graphing functions. We are going to graph a square root function by input and output. Reminder to have the steps pulled up on Google Classroom as you're doing this. Reminder that you can pause this as often as you want. You can rewind, even if it's 30 seconds at a time, to make sure that you're grasping the concept. So right here, I've got a square root function f of x equals square root of negative x plus 2 minus 3. I'm given inputs. We are going to graph this. First thing I'm going to do is create a table with x and f of x. I'm going to put my inputs right here. I gave you the inputs. That won't always happen, but that is happening this time. I'm going to put these numbers in for x one at a time, and then I'm going to evaluate it, see what it comes out to. So f of negative 2, what this means is that I'm taking function f and I'm plugging in negative 2 for all the x's. I'm going to substitute using parentheses, and then I'm going to calculate this. I can do it by hand. I can say negative 2 plus 2 is 0. Negative 0 is the same as 0. There's no such thing as a negative 0. 0 minus 3, which is negative 3. That is the technical way to do this. You'll notice I don't have function notation on every line, but because the equal signs are lined up, it is understood that that f of negative 2 is on each of those lines. I'll go ahead and put it on that last line. The other way that you can do this is you can put just this chunk into your calculator or into Desmos, and it will calculate it for you. So if I go to this page, I'm going to put this in projector mode real quick. My mouse will work. Okay. So if I calculate that, square root is going to be on your screen's keyboard down here. Negative, open parentheses twice, negative 2, close parentheses, plus 2. And then to get out of the square root, I'm going to press the right arrow. I'm going to do minus 3, and it will tell you up there. I know you probably can't see it on the video, but it says right there that it's negative 3. So that's where we can get that from. I can calculate the rest of these the same way. I can plug in my input of negative 3. So this is now f of negative 3 equals that. I can go to Desmos and change the negative 2 that I have there to a negative 3. And again, you probably can't see this, but it says negative 2. That could be gotten from taking this and doing the math with it. I can plug in negative 6, my next input. I'll do this one by hand. Negative 6 plus 2 is negative 4. A negative times a negative will give me positive 4. Square root of 4 is 2, minus 3 is negative 1. I can do the same thing with this negative 11, and it will yield 0. One thing that you need to know is that the reason that these y values came out pretty did not come out to irrational numbers, non-repeating, non-ending decimals. The reason that is the case is because I gave you the inputs, and I gave you inputs that would come out well. You'll see right here that the square root of 4 just comes out to 2. That 4 is a perfect square. You can take the square root and get a whole number. That's why each of these came out to something that was an integer. Integer being doesn't have decimals, doesn't have fractions. So if I graph this, you probably can't see the grid on the board, but you should be able to see the black. I'm going to label every 2 lines on this grid, if you can see it, as a 1. I'm going to label every 1 line on this x-axis as a 1. Okay. And so I've got negative 2 comma negative 3. I'm going to graph that. I'm going to graph negative 3 comma negative 2, negative 6 comma negative 1, negative 11 comma 0. And I'm going to connect those. That is what my graph looks like. You will notice that I did not continue it over here. The reason why is if I insert, for instance, negative 1 for my input, if I do f of negative 1, then I will get square root of -1 minus 3. And you cannot take the square root of -1. We talked last year in Algebra 2 about how that is an imaginary number, or this whole thing together is a complex number. We said last year that the square root of -1 equals I. You don't have to remember that right now, I'm just reminding you. So that is why this will not be graphable, is because when we get to -1, we get an imaginary number, or sorry, a complex number. We can graph this on Desmos. If we were going to graph this on Desmos, the way that we would do it, and the way that you're going to do it on your assignment, is that you are going to graph each of these ordered pairs that we did as ordered pairs: -2, -3, -3, -2, -6, -1. And you'll notice that as I'm doing this, I'm making sure to do it in parentheses. Let me zoom in on this some so it may be a little bit easier to see. And these are the same points that we got just a minute ago. We can graph the function as well. F of x equals square root. You can type SQRT, or you can use this button down here on the on-screen keyboard. I believe it was negative times the quantity x plus 2, and then outside of the square root minus 3. And you'll see that that red graph goes through each of the points that we got, which means that all this is correct. Those points are correct, and this graph is correct. I'm going to show you quickly one more that we did in class for those who were here in person. Give me just a moment to switch over. Probably should have changed this earlier, my apologies. So for this, it is going to be easiest to utilize Desmos to graph the actual points and calculate the inputs and outputs. So we have a table with x and j of x. Make sure this does say j of x, not f of x, since you are given function j. You may notice on these inputs and on this table that I did not do it from least to greatest. That is fine. It doesn't matter as long as you're connecting it. When you're connecting it, you're going from left to right. So I can calculate j of -1, 2 over -1 plus 3 minus 1. You can do this by hand, or you can put this part in the red box, not the whole thing, but just the part in the red box in the Desmos, and it will give you a output. If I calculate by hand, -1 plus 3 is 2. 2 over 2 is 1. Minus 1 gives me 0. 0 for j of -1. And then I'm going to do the same thing with a different input. I'm going to do an input of -2, which gives me 2 over -2 plus 3 is 1. So that's 2 minus 1, which is 1 for j of -2. And I'm going to do the same thing for the input of -5/2. So that's going to be 2 over -1/2 minus 1. Is that right? No, sorry, positive 1/2. Which gives me 4 minus 1, which is 3, or j of -5 over 2. And then when we get to -3, we're going to have something happen here. As soon as I plug in -3, I get 2 over 0 minus 1. This right here, this 2 divided by 0 is an issue. 2 divided by 0 cannot be done. It is undefined. You cannot divide by 0. So this one is undefined. G of -3 is undefined. We abbreviate that UND. And I'm going to do these just real quick in my head. Same process as before. I believe that is -2. Yeah. I'm going to graph these points that we have. Where that undefined is, I'm just going to skip over it. There's a feature of that graph right there that we're going to learn about in a couple of months. So I'm going to have -1, -2, -3, -5. When I do this, I'm going to have -1, 0, -2, 1, -5 halves, that's -2.5, 3. Something that I want to make sure to tell you is do not use mixed numbers in this class. If you want to think about them as you're going from the equation to the graph, or when you're going from the graph to the numbers, that's fine, but do not write mixed numbers. If you ever see a mixed number on a multiple choice, it is automatically wrong. And then we have undefined at -3, -7 halves, it's -3.5, it's down at -5, -4, -3, -5, -2. This connects, and this connects. I'm going to tell you what's happening at -3 in just a moment. Right now, I just want you to know that this is just the general shape of the graph. I'm going to graph it in Desmos. J of x equals 2 over, remember the fraction is done by the slash button, x plus 3 and -1. So this is what our graph looks like. Right here at where the x value equals -3, if we're graphing this by hand, and we'll talk about this in more detail in a couple of months, we're going to put a dotted line to show that it never reaches that line, and we'll talk about what that's called later. You'll notice that if you start on the right hand side and go toward that x value of -3, you start on the right and go toward or approach that x value of -3, it keeps going up. If you start on the left hand side and go toward, that approaches -3, starting on the left hand side, that goes down forever. So that is graphing by input and output. If you have any questions, ask them on Google Classroom or shoot me an email. Until next time, be well, do good.